YouTube manages an inventory of over 14 billion videos. The system has less than a second to sort through that catalog, select a few hundred highly probable candidates, and arrange them into a personalized homepage. To understand how the platform achieves that speed, we have to look closely at the machine learning pipeline engineered at YouTube's headquarters. Contrary to the broadcast myth, the algorithm does not push videos to a subscriber base. It functions as a query engine, pulling a specific video from the database to satisfy a single viewer session. Every pull decision is determined by two primary indicators: click-through rate, which measures initial interest, and average view duration, which measures the viewer's commitment to the content. When a channel's growth stalls, it is typically a mechanical failure in the signal generation pipeline. By identifying exactly where these two metrics degrade, we can reverse engineer that failure and restore distribution. The architecture of this system is documented in research published by Google's engineering team. It describes a multi-stage process, beginning with a phase called candidate generation. Candidate generation relies on a logic called co-visitation. If a group of viewers watches video A and then routinely watches video B, the system clusters those videos together to build a reliable audience map. Uploading unrelated topics across different niches shatters that co-visitation pattern. When the data becomes inconsistent, the system can no longer predict who the video is for, and the funnel stops flowing. The algorithm doesn't penalize this confusion, it simply becomes blind to the channel. This creates a null candidate signal. Ryan Trahan experienced this invisibility during a stretch of his early career where his videos were high quality but lacked a consistent topical anchor. Trahan had been established in the commentary and sports niches. He then pivoted to emulate the high-fashion social culture content popularized by Emma Chamberlain. Introducing sheer lace and high-fashion aesthetics conflicted with his existing athletic and commentary signals. This fractured his audience data, making his content invisible to the machine learning pool. Trahan only broke his plateau when he committed to a single, narrative-driven challenge format. The system requires topical clarity to function. Without a clean signal, a video never reaches the ranking phase. Earning visibility is only the first step. The environment for holding that attention is shifting, as television screens have now overtaken mobile devices as the primary way people watch YouTube. This shift indicates that viewers are adopting a leaned-back posture, engaging in the same long-form session behavior associated with Netflix. While overall watch time is rising, raw minutes are less significant than retention percentage. A 6-minute video with 60% retention will routinely outperform a 12-minute video that only holds viewers for half its duration. This chart shows the standard topography of a retention curve. While a gradual slope is normal, a sudden vertical cliff indicates a specific failure in the viewer experience. That drop represents bad abandonment. Viewers left because they hit a tangent, a pacing drop, or realized the video failed to fulfill the promise made in the thumbnail. YouTube monitors these exits because it prioritizes a metric called satisfaction. Through millions of daily surveys, the system determines if a viewer is actually glad they spent time with the video. Tom Scott maximized this by putting garlic bread in the stratosphere within the first 5 seconds of his video. He sacrificed potential watch time by cutting out filler, but he ensured every viewer left feeling satisfied. Artificially inflating duration with padding eventually triggers system-level deprioritization. Every added minute of content must earn its place by maintaining high satisfaction levels. This blueprint illustrates the 3 primary architectures YouTube uses to route videos. Each pathway functions as a distinct gate with its own set of requirements. Browse traffic is driven by recent viewer history and session consistency. If a viewer watches your last 2 uploads, your next video appears on their homepage, regardless of their subscriber status. Inactive subscribers do not drive browse traffic. Suggested traffic operates as a session matching engine. It groups videos by micro-niches, pairing a productivity channel with a relaxing architecture channel, because the underlying tone and audience vibe are identical. Search traffic rewards durable, consistent linguistic alignment. You capture these views by using the exact vocabulary your audience uses to describe the specific problem your video solves. Content must be aligned with the specific traffic source that dominates a channel's routing architecture. Mismatching the format to the source leads to wasted impressions. To determine where a video belongs, the system runs a controlled test, serving it to a small cluster of viewers to gather initial performance data. Engineers call this the explore-exploit problem. The system exploits proven winners for reliable performance, but must also explore unproven videos to prevent the platform from stagnating. This mechanic explains why adopting a saturated format like 100 Days in Minecraft creates friction for small channels. When every thumbnail uses the same day 1 to day 100 structure, the packaging becomes indistinguishable. When two videos look identical, the algorithm defaults to the exploit logic. It favors the larger creator because that channel provides a more reliable historical dataset for predicting viewer satisfaction. However, the system's prediction for your video is based on your own channel's history, not a global standard. Your last 10 to 20 uploads set the baseline expectation. If your next video beats your own historical average, the system receives a signal to expand the Explore test to a wider audience. This internal benchmark is the only hurdle that matters for expansion. To trigger the algorithm, you must outcompete the math of your own past performance. You can identify your channel's specific expansion formula by building a diagnostic audit. Start by isolating your last 20 videos in a simple data table. Populate the framework with 4 data points: title, click-through rate, average view duration, and views in the first 7 days. Once the data is entered, average them out. This bottom row represents the exact bar the algorithm has set for you based on your history. Look for your outliers, the videos that simultaneously overperform that baseline in all 4 categories. These rows isolate the specific instances where the algorithm had the highest confidence in your content. This is your signal cluster. It reveals the precise combination of topic, title structure, and thumbnail style that the system is ready to bet on. Your task is to repeat those successful variables deliberately. Success requires moving from a passive mindset to an engineering one. Shift focus away from subscriber counts toward the data signals driving the machine. The rules of the pipeline are consistent. You escape the null candidate filter through niche consistency and maximize distribution by keeping viewer promises immediately. Your primary competition is not the giant in your niche. It is the specific performance baseline set by your own previous uploads. Build the baseline spreadsheet and locate your outliers. Once you identify the variables that beat your own average, you can engineer your next upload to exceed the system's prediction. Approaching the entire recommendation system as a mechanical pipeline transforms your channel's growth into a manageable engineering task.
Let's discuss that in the comments section. And as always, thanks for watching Alux Live. Subscribe for more.